Okay, this is our second part of prime factorization. So, there's a story talks about your trip to Alaska, has different numbers in it, and we talk about prime numbers and composite numbers. So we'll skip that one for now. We'll talk about that in class. So here we've got a list of numbers from 1 to 30. If you remember back yesterday, or in our previous video, we talked about different numbers being either prime or composite, and we talked about that was based off of the number of factors. So I'm going to circle in, let's circle it in red, all of our prime numbers. Remember, these are the numbers that only have one factor, and those factors are 1 and itself. Now remember, I don't circle 1 because 1 is a special case, and we'll talk about that one later. So 7's prime, 11 is prime, 13, 17, 19, 23, and 29. So all of these numbers I circled in red are prime numbers. And again, that is the only way I can get to those numbers by multiplying is by multiplying that number. So for instance, 11 times 1. That's the only way. 4 I can do 2 times 2. 8 I can do 2 times 4, 3 times 3, etc. All these other ones have more than one factor. So prime numbers have only one factor. We list them 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. And then our composite numbers 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 1, 22, 24, 25, 26, 27, 28, and 30. Okay, here is kind of a neat little website, and it takes you step by step for factoring. Here's the website right here, and then that letter right there, that is a Q. It's a capital Q. That's a number 1, and a capital N. If you want to go to this website right here, you need to type this address in exactly as you see it. Capital letters where they belong, lowercase letters where they belong. So again, that's a capital Q, a number 1, lowercase j, 7, capital N, and 5. So let's take a look at some problems here. Which group shows the prime factorization of the number 16? I'm going to take a highlighter here. Okay, you see how it's talking about prime numbers? Well, 4 is not prime. 8 is not prime. So automatically, those two should be out. So I'm trying to get to 16. 2 times 2 equals 4. 4 times 2 equals 8. Did we get to 16? No. So 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. So our answer is C. Okay, so here we've got a factor tree. Factor trees are how we break apart or how we demonstrate how to factor a number. So 18, to factor 18, I could do 2 times 9. 2 is prime, so we leave it alone. And we have this 9. To get to 9, I can do 3 times 3. So the prime factorization of 18 is 2 times 3 times 3. So according to the factor tree, which of the following statements is true? So let me get my highlighter. The only prime factors of 18 is 3. Well, not only, because we've got a 2 there. The number 18 is a composite number, and that is true because we could factor it. The numbers 2 and 3 are composite numbers. No, 2 and 3 are prime numbers. the product of two prime numbers is always prime. No. If I multiply two prime numbers, I'm not going to get a prime number because I would get a composite number. So the only one that's true is B. That 18 is a composite number. So, which is a prime factor of the composite number 12? So we are looking for a prime factor. Well, 1's not prime. 4 is not prime. 6 is not prime. So what's our only prime number there? 3. I think I might have confused this by highlighting the letter there. I'll fix that. There we go. So 1's not prime. 4 is not prime. 6 is not prime, but 3 is. There we go. So let's review. Blank numbers are the basic building blocks of other numbers, and those are prime numbers. Blank trees help us factor composite numbers, factor trees, and a composite number has more than one set of factors. And that's all we've got for this video. If you have any questions, please write it up on your whisk and bring it to class.